Good morning and good afternoon, and welcome, everyone. My name is Terrell Tanaka, and I'm a product manager for Agilent's Calibration and Repair Services. I'll be your host for today's webcast titled De-Mystifying Calibration Accreditation. This webcast is the third of four in our calibration webcast series. For those of you who missed the first two, we'll spend a moment reviewing the highlights from the earlier webcasts that pertain to our topic today. Just a few notes before we begin. This is a lecture-style meeting, so sit back and relax. However, we encourage questions, so please enter at any time your questions in the chat box or window. Just remember to submit your question to all. The questions will be answered at the end of the presentation, and if we run out of time and don't get to all of the questions, we'll respond to the remaining questions via email. This webcast will be recorded, so you can review and share it with your colleagues at any time. Finally, at the conclusion of the webcast, a brief evaluation form will appear when you close the WebEx session. Your feedback would be greatly appreciated. Now, let's move on to the presentation. Joining us today is Bob Stern, a senior metrologist with Agilent. He has a master's degree in electrical engineering from the University of Wisconsin and has worked for 6 HP or Agilent divisions, serving as an applications programmer, engineer, and product marketing manager for a variety of RF microwave instruments and systems. Bob represents Agilent on several calibration standards committees at NCSLI and serves as the co-chair of the 174 Standards Writing Committee. He is currently leading efforts to align Agilent's calibration service deliverables with ISO 17025, ILAC G8, ILAC P14, and ANSI Z543. And we're very pleased to have as our second presenter, Ryan Fisher, who is the Calibration Program Manager at Laboratory Accreditation Bureau. Ryan has broad experience in dimensional, physical, and mechanical calibration, and was deeply involved in the preparation, assessments, and actions to achieve ISO IEC 17025 lab accreditation. He led the startup of a brand new laboratory as Technical and Calibration Lab Manager, and currently serves as Calibration Program Manager at LAB. Ryan is also active in NCSLI and is chair of the 183 Accreditation Resources Committee. We especially appreciate Ryan's help in arranging a thorough review of today's material with the accreditation bodies and the other members of the 183 committee. Welcome, Ryan and Bob. You now have the floor.
Thanks, Terrell. So before we begin, just an opening question. When you're traveling in your car and you're on an interstate, how fast are the cars going on the highway? Here's a hint. The answer that I'm looking for is not the posted speed limit. Okay, that's a sound that probably we've all heard once, at least once in our life. The speed limit is certainly important, but the real answer is, what are the police enforcing? And similarly in calibration, when an end user sends in their instrument for calibration according to 17025 or Z543 or one of the standards that we've been talking about, and a laboratory says, yes, that's what we're doing, is it just what the calibration lab claims? So similarly, what I would like to stress here is that it's really about what is enforced, or in other words, what was the calibration lab assessed to by a accreditation body. So I wanted to do just a little bit of review of where we are in the seminar series. We have 7 YouTube videos, and 3 of these, the topics in the first 3 were covered on November 13th. And then last month, in December, we also talked about traceability and standards compliance. Today, of course, we're going to be covering the topic accreditation, and there's one more in February on the 13th that'll be of interest to those of you that care about complying with Z540.3. So here's some links, and all of these slides, by the way, will be made available to you. So here's some links to the YouTube videos that we have, and as of yesterday, there's a new one on accreditation that's a little bit shorter in terms of content covered, but it's interesting nevertheless, 10.5-minute version or treatise on accreditation. So When you send your instruments in for calibration, I'm speaking now to folks in particular that are end users or folks who own equipment and are responsible for measurements. When you send that into calibration, either to your own lab if you have one or to an outside lab, what do you expect them to do? Well, certainly you're thinking about your own answers, and while you're thinking about that, I want to just give you a few points. I hope that your answers would include what I've got listed here. So number one, you want to characterize a device or instrument, and you do that by making actual measurements. Well, as soon as you make a measurement, the next thing you want to know is how accurate was that measurement. And in the metrology world, we use the term measurement uncertainty. So that's a standard deviation representation of all of the sources of error combined in an industry standard fashion. Well, once you have a measurement and you know what the statistical measurement uncertainty was, you're then in a position to say, did that measurement pass or fail the warranted specification? And in the metrology world, we call that a statement of conformance. And 17025 tells us that you're supposed to advise the client if your device or instrument is found out of tolerance. So at Agilent, what we do is, unless someone instructs us otherwise, whenever we find an instrument out of tolerance, we go ahead and adjust it. We repeat the calibration procedure and then provide the customer with both sets of measured data so that they know how it performed when it came in and how it is performing as we've sent it back to them. So for accreditation, that is really a confirmation of the competence and skills of a calibration laboratory measured according to the standard ISO 17025 primarily. And that is performed by someone who knows the standard really, really well, namely an assessor. And these folks work for accreditation bodies, for example, the Laboratory Accreditation Bureau, from where my co-presenter Ryan is from today. One last slide before we dive in on the details of accreditation. I've encouraged you engineers throughout this series to become familiar and think about those specifications that you depend on most when you're using an instrument. And these are probably pretty easy for you to think about because they're the ones that you labored over most carefully when you decided which instrument to buy. Okay, so if you know which specifications are most important to you, those are the ones where we recommend you look at the performance tests that correspond to those in your measurement report. And speaking of measurement reports, that's really the physical evidence of work performed. So at Agilent, we believe that you should get a measurement, or you should get a report of all of the measurements performed, and that's what we do. And finally, just on sort of the whole topic of do you get measurement results, do you get a report, since this is a North American audience, I like to think of this as really, this is when everyone should be from the state of Missouri. So when it comes to Cal reports, show me the data. That's really what we're talking about. I guess some of our marketing people have heard me say this often enough. If you're reading in trade journals, you may see this image of a young man looking at a blackboard, and what they're saying is you had to show your work all throughout elementary school and ask your Cal provider to do the same. So I believe, just in the spirit of measurement integrity, that it's really important to go back and look, how did my instrument perform? And you can only do that if you have the measurement results. So we certainly think that's the right way to go, and that's why we try to do that. So with that said, for introductory and a little bit of review there, I'd like to turn it over to Ryan.
Thank you, Bob. The rest of the presentation, we're going to take a look at accreditation, why it matters, even if you don't order an accredited Cal. And we're going to take a look at this from a couple different standpoints, looking at it for the use of the accredited symbol for an accredited calibration, and the use of the symbol when results are reported when it's not covered by the scope of accreditation. So with this, the first thing we have to take a look at is what is this formal definition of accreditation? when we take a look at accreditation according to 17,000, the definition is defined as a third-party attestation related to a conformity assessment body, conveying formal demonstration of its competence to carry out specific conformity assessment tasks. First off, I really have to apologize for Bob's favorite wordy definition, and you'll have to forgive Bob since he's still dealing with the Wisconsin Badgers losing the Rose Bowl. But looking at the definition and breaking it down into simple terms, what it's basically saying is that accreditation bodies are sending out qualified assessors to the laboratories to perform an assessment of not only the quality system but of the scope of accreditation, covering these bullets here that we see on the screen. So the assessors are reviewing the technical competence of the staff, the validity and the appropriateness of the test methods, traceability of the measurements and the calibrations to not only national standards but international standards, the suitability, calibration, and maintenance of the test equipment, what kind of environment the calibrations are being performed in, what requirements are in place for sampling, handling, and transportation of the test items or the equipment, and what I would consider the most appropriate aspect of the accreditation, ensuring that the quality of the test and calibration data is sufficient. So as we move through and start to understand what we need to be accredited for, we have to take a look at the standards. First off, we've got the standard of ISO IEC 17025, and this is a standard that all accreditation bodies under the ILAC umbrella will assess their laboratories to. There's some others that are listed here, but the first thing that we need to ask ourselves is which standard do we need to comply with according to our requirements that may be given to us by our customers. The second question that we need to ask ourselves is what do we need as a laboratory or an organization? And when we ask that question, we could extend the quality system to further include requirements exceeding our customers' expectations, going that extra step for reassurance to the system. And third is what kind of training is needed for the personnel when we're complying with these requirements. As we can see the additions here, here in the United States, we have a couple that the accreditation bodies will assess to, Z540-1 and Z540.3. But these other ones do complement these standards, one being, the first being the GUM. The GUM is referenced inside 17025 as a reference. When we look at ILAC G8 and ILAC P14, these documents accompany the accreditation through recognition to the ILAC, which you see the symbol there on the right. As a makeup of these standards, there's always the review and what I would consider the consultancy of ISO 9001-2008. Under the ILAC umbrella, accreditation bodies will not assess to the requirements of ISO 9001-2008. That is for another body, I believe it's called IAF. So as we understand the requirements that we have to follow, taking a look at the big picture and a pecking order of recognition and accreditation, it really starts with the ILAC MRA. MRA is the Mutual Recognition Arrangement. And the link that we see here under the title will direct you to all the signatories that are under the ILAC umbrella. But what ILAC is doing is they're performing an evaluation of the accreditation bodies to certain evaluation procedures. Their main thing that they're looking for is compliance to the requirements of ISO 17011. Now, on top of that, there are other documents that accreditation bodies are being evaluated against, and in particular, there's a few of them that we're going to look at today. But ILAC guidance documents such as ILAC P14, ILAC G8, and ILAC P8 for the use of the AB symbol. So what the ILAC body will send out regional bodies such as APLAC, IAAC, and others such like that throughout the world. But what they're doing is they're ensuring that the accreditation bodies provide a competent assessment and accreditation to the requirements of 17025 and ISO 15189. As we look at the symbols to the right of the slide here, these are the accreditation bodies that have participated in or are currently participating in the NCSLI 183 Accreditation Resources Committee. So we can see that there's this unified front underneath this committee, and also as signatories to the ILAC MRA. So as we move through the pecking order and what I would consider the meat and potatoes of the accreditation.
Hey, Ryan.
Yes.
You're getting to be a little bit like too much metrologist there, even if I am a Badger from Wisconsin.
I'm sorry, Bob.
So what we want to let everybody know is that there's a lot of meat in these standards, and the people who do accreditations, namely all the folks, assessors, and all those organizations on the right, they know all that stuff. That's what they do. So we're going to continue a little bit with the scope of accreditation and hand it back to Ryan.
Yeah, and looking at this scope, and I really consider this the meat and potatoes of the accreditation, and looking at how the process works. The first stage is that the Cal Lab will contact the accreditation body and discuss with them and identify which parameters they would like to seek accreditation for. The second step has quite a few things here, but essentially what is going to happen at this point here is the accreditation body will send out an assessor, and that assessor will review the quality system for compliance. They'll spend time with the technicians assessing the competency and their measurement technique to measure a particular parameter that's identified on their scope. They'll also assess the uncertainty of measurement, not only analysis, but also the procedure for uncertainty. And they'll assess the traceability path to the SI unit. And here we've got some examples of national metrology institutes. Here in the United States, we have the NIST, United Kingdom, we have NPL. In Germany, we have PTB. In Japan, we have the NMIJ. So as we start to take a look at some examples of the output of accreditation, here we've got an example of a certificate of accreditation. And it shows that the laboratory has been assessed to and meets the requirements of the international standard of 17025, and nationally in the United States for Z540-1 and Z540.3. Here we can see the certificate is fine and dandy, but the real thing that we want to take a look at is the scope of accreditation. So inside the scope of accreditation, it describes the laboratory has been successfully assessed to particular parameters and standards. Here we can see that the scope is made up of several different things, and looking at this scope as a whole, this is by definition the calibration and measurement capability of the laboratory. And the calibration and measurement capability of the laboratory is the parameter that the laboratory is calibrating to, the range, the expressed uncertainty, the reference standard used for the calibration, and in this example here, the locations at which the calibrations are taking place. But looking at the scope, there's a couple areas that we really need to focus on to make sure that the laboratories have the capabilities to perform the calibrations. And looking at a couple different examples here, we've got the two different laboratories here. We've got CalLab ABC and CalLab XYZ. We can see that they've been accredited to the same standards of 17025, Z540-1 and Z540.3. But as we take a little bit closer look at what the actual capabilities are, we really have to understand, what do we need to know out of these two certificates of accreditation. So as we break down the scope of accreditation, we can see some noticeable differences between the two laboratories. XYZ lab, we have all these different parameters that they've been accredited to. But as for ABC laboratory, only about 25% of those parameters have been assessed and successfully been granted accreditation for. So as we take a look at the risk of this situation, I'd like to turn it over to Bob to further discuss risk for you to the unaccredited parameters.
Well, thanks, Ryan. So risk is really all about you make a measurement that may be either pass or fail, in other words, measured as observed inside a specification, but in fact the true result may be on the other side of the specification. Formal literature, I think they call that consumer risk. So what you see in front of us now is two measurement results, an A and a B. These would be examples of a single measurement on a given performance test by two different laboratories. And in this case of our example, you see that they got the same result. So you might say to yourself, oh, okay, well, both say the same thing. This instrument is ready to be used for another calibration period. But you heard us talking about measurement uncertainty before, so let's put that in our example as well. And the yellow areas now show what is the expanded measurement uncertainty. So this is two standard deviations either side of the measured point. And when we look at it this way, we go, okay, so where is the true measurement answer that has no error associated with it? And unfortunately, we don't know where the true answer is. The only thing that we know for sure is the length or the size of the interval of the 95% expanded measurement uncertainty, and that there's a 95% coverage probability that it lies somewhere within there. Well, that's somewhat disconcerting if you realize that any of the areas in red, if that's where the real true answer lies, those represent the risk that your instrument is operating out of spec. Now, these can be identified with probability density functions and numerical integrals and all that kind of stuff. But you know what? You don't need to do one of those. You can kind of look at this, and with your own eyeballs, you can see that if this represents a probability distribution, there's a pretty good chance that on the right-hand side, the real performance of that instrument is that it's out of spec, and that would be true. So one takeaway from this is that the actual instrument accuracy that you can depend on when you get it back from the Cal Lab is really only as good as the expanded uncertainty interval from your last calibration. Now, why are we telling you this with respect to accreditation? Well, the reason that I tell you about this is the following. In my experience, I have seen multiple cases where calibration labs offer to do work in areas where they are not accredited, and even although they are not listing in their calibration measurement capability, so you officially the only thing you know is that you don't know what their best measurement capability is. But unofficially, in my experience, oftentimes what that means is that they're using older instruments. And I can tell you, as more or less an expert in block diagrams and RF microwave instruments, that in the last 10 years we've made tremendous strides in terms of moving from analog IFs to digital IFs, all the old horrendously inaccurate log amplifiers, all sorts of different factors, some of which I mentioned in the last webcast. Those have been replaced with digital filtering and microprocessors performing the log function. So the result is dramatically increased accuracy, dramatic enough that it actually, the way that I've represented them in this chart, is very realistic. So it's important, as we say, to know, so what is the accreditation or the scope of accreditation for a Cal laboratory that you're considering using? And at Agilent, we make it real easy to find out what those scope of accreditations are for any of our labs around the world. And in fact, you can either go to that short link that's at the bottom of the slide, or if you know which accreditation body we're using, for example, out of this chart here, you can go to one of, we use 15 different accreditation bodies worldwide. And any calibration laboratory is always, if they are accredited, will be listed with the accreditation body that has done the assessment. So now what we'd like to do is to summarize just this first portion of how important accreditation is, even when you're not asking for an accredited cal. So I hope that pretty clearly we've made the case that it's important to review the scope of your calibration supplier, and what you're doing when you do that is number 2, which is to figure out what is the does the scope of accreditation cover those things which are important to your company. Now, if there's any parameters in your instrument which are not covered in the scope, then if it was me, I would certainly be asking that calibration lab, all right, you don't seem to be accredited there. It's a bit of a red flag, but can you tell me what is the expanded measurement uncertainty for, and I would give them a specification that mattered to my organization. Now, that may sound like a tricky question, but it's really fair. And if you ask that to somebody from Agilent, you might throw off one of our technicians, but pretty quickly they'll recover and realize that they can either show you a calibration report from another instrument they just did, or it's real easy for us to go in our system and pull down a sample of a calibration that we have done either at that location or anywhere in the world, which does include measurement uncertainty, and then just simply black out the customer's name and location, and we can share that with you so that you can take a look. So as Ryan and I are both trying to emphasize, when you send something in for calibration, you expect it to be measured. You expect them to tell you whether it passed or not and adjust if necessary. And the risk that when it comes back of being out of specification is going to be lowest if the expanded uncertainty is known and is significantly smaller than the instrument spec. Okay, I'm going to send it back to Ryan. Now we're going to talk a little bit about the specifics of when you actually ask for the accreditation body symbol on your calibration report. Ryan?
Thank you, Bob. Really the first question that I have to ask in this scenario is who's guilty of reviewing a certificate just for the accredited logo or the accredited symbol? I can virtually see the hands raising. But looking at the requirements that go into this, it's quite detailed. And when we take a look at what we have in the Americas, we have several different things that go into this. First of all we have is the requirements of 17025. This is the standard that we're being assessed to, and what the accreditation body is providing the accreditation on. But as part of that, we've got the ILAC document P8. And this is a document that accreditation bodies have to follow when laboratories are using their symbol, and inside the P8 it describes when we use the symbol on the certificates, calibration labels, advertising and publicity, and et cetera. But also we have ILAC P14. ILAC P14, of course, is the policy for the uncertainty in calibration. And inside that policy, it describes how the uncertainty is to be reported, and following the guidelines for the expression of uncertainty of measurement. But when we look at the measurements itself, we have to make sure that the measurements are within the scope of accreditation. If they're not, we have to segregate them somehow and identify them as not being part of the scope. So when we look at the rest of the world, we've got Europe, Japan, and the Far East. The bullets above for the Americas all apply, but in those regions, they also add into their requirements ILAC G8 for reporting compliance with the specification. Here we've got the accreditation body's symbols that would show up on calibration certificates or test reports. And once again, these are our accreditation bodies that participate within the NCSLI 183 Accreditation Resources Committee. But when we look at ILAC G8, essentially the title speaks for itself. It's the guidelines for reporting compliance with the specification. And this means any indication of compliance to a specification, whether it's good, bad, green, red, in or out, etc. But when we take a look at the actual document itself, we want to focus on paragraph 2.3. And it talks about a few different cases here, and I want to focus on two of them for this presentation. The first one is case 2. Here we can see a measurement is found within a specification, but when we extend the uncertainty of measurement, it breaches that specification limit, essentially saying that we cannot make a statement of compliance. When we take a look at case 3 is identifying a false measurement, or a measurement that is outside the specification limit, extending the uncertainty into the compliance statement, and effectively also stating that we can't provide a statement of compliance in either of these cases. But the core of this is by the quote here, it's not possible to state compliance using a 95% coverage probability for the expanded uncertainty, although the measurement results in this case here too is below the specified limit. So as we look at an example here, and this is an example that Agilent is working on, and they're identifying this with a P double dagger. And when there is this case of case 2, there's a few different areas that we have to take a look at. First area is 17025 at 51042. Here we've got the measured values of the equipment were in specification at the points tested, with the uncertainty not taken into account. So when we look at ILAC G8 and paragraph 2.3, a portion of the extended measurement uncertainty intervals centered about one or more measured values exceeded the specification. Okay, so now with paragraph 3.2 in G8, consequently, compliance with the specification cannot be declared based on the stated coverage probability. Okay, this is an example of case 2, and as for case 3, when we look at reporting failed results, same 3 scenarios apply that we saw on the previous slide with 17025 and ILAC G8. But when we look at 17025, one or more measured values of the equipment were outside of the specification at the points tested, with the measurement uncertainty not taken into account. But when we look at the next step, a portion of the the expanded measurement uncertainty intervals centered about one or more measured values were in specification. So once again,
hey Ryan, I wanted to add one thing here, which is those of you that are listening today, if you look on our reports today, generally you won't find these new symbols just yet. This is work that we've recently completed. This is the new Agilent internal standard, and part of the reason why we're sharing this today is that this is where we're heading. So in a year from now, we may very well have 500 or more models that are represented this way when we do the Agilent Cal plus uncertainties. But we're also trying to make a conscious effort to share what we believe is a best practice with everybody else in the industry. So there's no proprietary naming rights to P double dagger or F double dagger. They're just good terms that really work well, and we've checked. They seem to work well internationally. So if any other calibration labs are out there, if you're thinking along the lines of, you know what, we really ought to be doing a better job of marking according to ILAC G8, you are more than welcome to use these symbols. Ryan?
Thank you. Thank you for finishing up that discussion there. The next area that we have to pay attention to is ILAC P14. And this is another document that ABs have to follow and enforce. But when we take a look at the specifics of ILAC P14, we want to focus on Section 6 of the document. Particularly in Section 6.1, the second sentence, Here's where we have the requirement that accredited labs shall report the uncertainty of measurement. And we can see the first paragraph is a restatement of 17025. But really, when we're taking a look at the second sentence there, the accreditation bodies are required to enforce that the laboratories report the uncertainty. As we look at sections 6.2 through 6.5, we can see that ILAC P14 has adopted the ISO GUM methodologies. And at this point here, I'd like to turn it over to Bob for a discussion of calibration certificates.
Okay, so you've been hearing about sort of the general requirements there from Ryan on what do you have to do when you put the accreditation symbol on a certificate, and we just thought we'd show you a short example here. So this is the front page on an example. This is a microwave signal generator, I guess. And so what you'll see is that it's the symbol. In this case, this particular lab in California is accredited with A class. We are allowed to use by them, and by the mutual recognition agreement, we're allowed to use the MRA symbol as well. And we state on the front that it is compliant with both 17025 and in this case also Z543. But perhaps the real meat or the important part is really always on the measurement report itself. And in the red circle there, you can see towards the bottom the measurement uncertainty shown in the report. So every data point is also going to include the ISO guide GUM measurement uncertainty. And so that's also shown in this particular report. This one's also shown graphically above as well. But the important thing is that it's shown and that it's in the report. So we're at a point now to kind of summarize many of the main points. Earlier on, we focused on just how important it is to engage a calibration lab who has a scope of accreditation that includes the types of parameters in the discipline that your device or instrument requires for being tested. One thing I didn't mention then, but I would like to say before we leave today, is that at Agilent Technologies, we try really hard to ensure that whether these measurements are made at one of our service centers or on site, that those people and the processes and everything else are accredited in essentially all of the parameters that we are using for that instrument. And we try to do that regardless of whether someone actually is asking for the accreditation body symbol or not. We're trying to be the premier measurement company, and it's our belief that if that's your goal, then that's what people would expect. And in fact, we believe people have a right to expect that anyway, but we're trying very hard to do that whenever we can. Finally, I do want to mention that, as always, there are some services that we provide where we are not including the measurement uncertainty, and I just want to make sure that everybody understands with Agilent Technologies, we don't change the test procedure that we're using. We don't change the test equipment, so test points don't change. The test procedure doesn't change, the lab standards, and therefore neither does the measurement uncertainty. So there are cases where you may not get the measurement uncertainty reported, and those are a little less expensive. But please rest assured that the measurement uncertainty has not been compromised in the course of doing that. So just one last little detail. Today Ryan and I have been talking about demystifying the otherwise complicated topic of accreditation, and we're going to answer questions in just a minute. But I do want to just mention, while I have this moment, that there is another webcast coming on the 13th of February, and that one's going to be about how to comply with Z540.3. If you are somebody that has Z540-1 requirements today, then I would highly recommend you try to attend that session, because I think you'll find it very interesting, and it's highly likely that if you don't already have Z540.3 requirements, that you very well may have them in the near future. So with that, we'd like to go, if there are any questions, Ryan and I will attempt to answer them.
Okay, thank you very much, Ryan and Bob. And we do have several questions in the queue, so let's see. Ryan, why don't you take this first one? The question is, should a Cal Lab seek a higher accreditation than the company's quality system?
Looking at the accreditation itself, there really is no higher accreditation that can be offered when we take a look in terms of the ILAC signatory umbrella. But there are a couple things that may be specified by customers or even regulators that they may need to seek additional confirmation on their quality system. So speaking in terms of higher accreditation than the company's quality system, it really just depends on what the customer is expecting the calibration provider to be in compliance with.
Okay, very good. Thanks, Ryan. Bob, I'll give this next one to you. The question is, how often does measurement uncertainty get revisited and reevaluated?
Okay. The answer to that is it depends. It depends on how often. But first of all, we have to go back and see how did it get developed and why would you need to change it. So real quickly, when you're developing a calibration test procedure, as part of that effort, for the measurement uncertainty, you're identifying what are all the sources of error, and then you're quantifying them, and then finally you're combining them. Well, if you don't change the test procedure nor change any of the test standards, you can go for many years with the same measurement uncertainty. But as soon as you change the procedure or any of the test standards, then you need to go back and revisit that and see which terms change and do an update.
Okay, thanks, Bob. Ryan, this next one is a question and a follow-up comment. The question is there a requirement to state compliance to a specification? It appears that many labs are avoiding the G8 requirements by reporting uncertainties, but not making making no pass-fail declarations.
Yeah, that's actually a pretty good question and a very hot topic that's going through our industry. But the first thing that we want to take a look at is the requirements of 17025. When we take a look at 5.10.4.2 of the standard, it has a couple of little gray areas, and gray areas I mean by terms here is the standard says when a statement of compliance is made, if a statement of compliance is made. So it really puts the onus on the calibration provider and the customer to determine if a statement of compliance is needed. Now, when we take a look at the comment of avoiding G8, this is one of those areas as well that has to be worked out with the customer when the calibrations are being performed through contract review. So probably the most headache that comes out of this is that the standard allows us wiggle room. Now, when we look at ILAC P14, it does state that uncertainty has to be identified, and then when we look at G8, it goes into when statements of compliance are being made, so they're kind of talking to each other. But the start of all this comes with the requirements of the standard and working out those requirements with the customer.
Terrell, could I add a comment to that?
Yeah, go ahead, Bob.
I think many in the audience know that I don't mince words, so here what I would say is if a calibration supplier has ISO Guide 98 measurement uncertainty, then it's very easy to take that into account. For example, they could implement the P double dagger or the F double dagger sequence that Agilent is using. So the hard part of that work is developing the measurement uncertainty. If you have that, it's easy. So if I were a customer and I was hearing what Ryan just said, what I'd really want to know is, do you have it or don't you? Because if you do, why is it so hard? And if you don't have it, then that's a separate discussion. So I just thought I would add that in, that really, again, measurement uncertainty is about how good is the measurement. There is an international standard way of doing it. So if I were to receive a report like that and someone was demurring on declaring that, I would be asking very simply, do you have the measurement uncertainty according to the GUM or don't you?
Yeah. Good point. Okay, we've got one last question, and Ryan, I'll let you answer that. The question is, how can an accredited lab improve or change their measurement uncertainty claims on their scope?
There's really some information that we have to understand first, and that comes from the accreditation bodies. And I would strongly suggest that you contact your accreditation body to figure out what the process is to update the scope. But when we look at the values, and Bob kind of touched on it earlier, is that when we're changing our values, there's multiple things that we have to take a look at. Did a calibration provider give us a new uncertainty for the calibration service? Did our environment change? Did our procedure change that would affect the repeatability, the reproducibility of the process? So there's a few things that go into that before we can determine if the scope is changing. But if it gets to the point that the scope is able to change, contact your accreditation body to figure out what kind of change notices would have to be completed to ensure that you've got the most up-to-date information on your scope of accreditation.
All right. Well, okay, well, it looks like that's all the time we have for today. So, first of all, great big thanks to both Bob and Ryan. And as we wrap up today's presentation, here are a few last items. First of all, a reminder that anyone can participate in NCSLI committees. The next meetings are scheduled during the Measurement Science Conference in March, as well as the NCSLI in July. We will be emailing you a link when the on-demand version of the webcast is ready to view. If you're interested in communicating with Bob directly, you can reach him at bob_stern@agilent.com. And don't forget to complete the brief survey at the conclusion of the webcast. We appreciate your taking the time to provide your feedback. And thank you again for attending today's event, and have a great day.